Hello everyone, I'm Armin Nikhtel and I'm going to talk about virtual memory in operation system design. Data is growing fast and virtual memory improves the way we interact with computers today with big data. No more memory is full error messages. They make it possible to do multi-process and multitasking much easier. Utilize a smart use of free hard disk space and use it as a process memory. Higher storage capacity and lower performance is one of the main memory limitations. Nowadays processors might require more than available main memory. Main memory is fast, but is limited in its capacity and is expensive to add higher capacity. Hard disk is slow and cannot be used as only source for main memory. That's why virtual memory solves this issue by utilizing both main and secondary storages to be used by processors. Virtual memory allows non-frequently used data to be stored in secondary storages. It shows both main and secondary storage as a unified memory for processors. Virtual memory allows for more processors to run in parallel. Because it hides limited capacity of main memory from processors, it keeps important and more frequently used data in main storage, and it moves background data that are not being used frequently to secondary storages. Each processor manufacturer defines a page size where each page contains a set of data for processes. Each segmentation contains a set of pages, and this segmentation can be controlled by a programmer for a set of data. Virtual memory decides which page to reside in main memory and which page to reside in secondary storage. Virtual memory follows three important sets of policies. Fetch policies, which decide when a page should be brought to main storage. Placement policies decide when a page is no longer necessary to be kept in main storage. And replacement policy decide when a page needs to be brought to main memory, but main memory is full. Therefore, one of the main storage pages must be sent to background to the secondary storage to free up the storage for new process. In Windows, virtual memory control via page file, where there is a file created and managed by Windows on system partition. Size of page file can be automatically and dynamically managed by operation system, or user can limit this file size. It is designed to determine CPU paging size and operate from 4 KB to 64 KB page size. It uses address map for this virtual memory. In 32-bit processors, it allows 2 GB of usable memory per process. In 64 processors, it allows 8 TB of data to be stored for each process, and in IA64 processors, it allows 16 TB of data to be stored for each process. Linux swap space uses three-level page table structure consisting of page directory, middle directory, and page table. Page directory of an active application always reside in main memory and follow page size. Page middle directory point to another page in page directory, and it is spread across the multiple pages. All processes in Android access memory through OS memory management. Low memory killer ASHMEM and PMEM control available memory in Android. Low memory killer is a kernel extension in Android operation system that activates when main memory storage is getting full. LMK help process to save process data to secondary storage and free up the memory. If a process didn't free up memory after LMK sent a signal, LMK will terminate the process to free up the memory. For current mainstream server and home users, 64-bit structure is more than enough regarding virtual memory. Virtual memory is working good and it has helped to increase performance of computers around the world. For heavy processes that require more than current mainstream availability of memory, usually corporates are moving to cloud computing, so that end user does not need to have huge amount of main memory in his own systems. Corporates do all the heavy processes and hold the big data in their own computer memory, and they process and send the end result to end user as an optimized resource. Thank you everyone for your time and attention.